Hello everyone, this is TSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is daily temperatures. Let's jump into the problem statement. Given an array of integers, temperature represents the daily temperature, return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer I as 0. Okay, so basically we'll have an input vector, right? So let us assume we have something like 73, 74, 75, 71, 69, 72, 76, and 73. Okay, so this was the vector that was given to me. This vector, which is given to me as an input, is representing the temperature on each day, right? So that means on 0th day it was 73, on first day it was 74, second 75, third 71, and so on. Okay. So this has been given to me. Now, from this given input vector, what I want to do is I want to generate another vector that is of similar size, right? So in this case, we have a vector of size 8. And now in this vector that I will be returning, what I want is I want to have here, for example, if this vector is answer. So in answer I want to return the number of days I have to wait to get a warmer temperature. Okay. So basically that means if I was standing on the 0th day, it was 73 degree, let us assume, right? So when will I get a temperature that is warmer than it? If I look at this array, this part of the array, right? I can see just right next to it, I get 74, which is one greater than where I was standing, right? So that means I just need to wait for one day and then I'll get the answer, right? So here in answer vector, I have to put a 1 here because it is representing the number of days I have to wait for a warmer temperature. Similarly, if you are standing on the first index, you will check for the array from index 2 till last, right? And you will see just right next to 74, you're getting 75. So basically, it needs to be minimum, right? Closest, you can say, closest maximum, or we can say closest temperature which is greater than the current temperature. Okay, so this is what we are going to do. For each temperature we need to figure out the closest temperature which is greater than the current temperature. This is to do. Okay, now as we've discussed the problem, there's one more thing that we need to keep in mind. For example, if you're standing on the last index, that is 7th, right? And you have a temperature 73. You do not have anything beyond it. So here your answer in the answer vector will be 0 because there is no future day where this can be attained. Similarly, if you stand on the 6th index, as only this portion of the array is left, that is only one block and the value is not greater. So for 6th also, answer 6, that means the index being 6 in the answer vector will also be 0. I hope the problem is clear. Now let's talk about its approach. So when I was discussing the problem, I'm pretty sure you would have built the brute force approach. If you have not, no worries, we'll discuss it. So basically, brute force is what comes into your head for the first time you try solving this problem, right? You do not have to think of the time or space complexity. We can always optimize it. Once you know how to solve a problem, optimization can be done. So what is the first thing that I can do? I see that if I'm standing on any index, for my searching array, it gets reduced, right? If I'm standing on 0, then my searching array becomes 1 to n. If I'm searching for the current index that I'm standing on 3, then my searching space becomes 4 to n, right? So when I am doing something like this, I'll like write it for a few more. So if I was standing, my current index was 0. So my searching space is between 1 to n. If my current index is 1, my searching space is between 2 to n. If I am on second index, my searching space is 3 to n, and so on. So from this, what am I able to understand is I can have nested for loops, right? And when I'll be having these nested for loops, I can stand on one index and use the nested for loop for figuring out the closest temperature which is greater than the current temperature. Okay, so this is the brute force approach that is coming into my head. So when we see we are going to work with nested for loops, we know directly that the time complexity will be O of n square. That is because if you are standing on one index, you're figuring out the rest. Then you're again standing on one. So that means you're iterating twice on the array, right? So that is why the time complexity is O of n square. And this approach will give us a TLE. Okay. So what I have to do is, now I know the brute force that if I'll do this, I can solve this problem for test cases that do not have a very high time complexity, right? So if I want to solve all the test cases, I need to optimize my brute force approach. So for the purpose of optimization, what I can do is, see, I understood that when I was talking about the array, right, that was 73, 74, 75, 71, 69, 72, 76, 73. This was the array that was given to me, right, as my input. So I know at even in my brute force, what I was doing was I was standing on one place and I was figuring out the next greater element. So whenever you figure out the next greater element, it means the closest next greater from the index you are standing on. So this is a very standard question for next greater element. Basically, what I will be doing is, here I will be figuring out the next greater element corresponding to each element that is given to me. And to do that, I'll be using something like a stack. Now, why will I be using a stack is because stack works on LIFO. Now, what is LIFO? LIFO says last in, first out. So basically, if I start traversing from the right side, okay, so for example, I was on 73, right? There is nothing to the right of it, so I can return a 0. When I'm standing on 76, I can put the 73 in my stack, right? And when I'm standing on 76, that means when I'm standing on the index 6, I can compare it with the previous value that was in my stack and I can see is it greater or not. As you can see, it is not greater, we'll pop it out and my stack will be empty. That means there is no value possible. Then I'll put another 0 here, right? You go to 7 and then you will push 76 here. You can push the number or the index, whatever suits you. But in this question, I will prefer that rather than pushing a number in the stack, you should push the index. Now, why is that? It is because we have to give number of days, right? So, for example, if I was on 75 here on the second index, right? And suppose we have 76 here. So, I have to tell how many days. So, it will be 6 minus 2, 4 days, right? That is why I push the index. I hope this approach is clear. I'll quickly code this up, then we'll have a dry run. You will have an even better understanding, and then we can discuss its time and space complexity. Okay, so this is the code. Basically, what I'll be doing is, let's quickly create an answer vector, right? I'll run a for loop from the right side. So that will be temperature, that will be, let's create int n, that's a variable which is corresponding to the size of my vector that has been given to me, right? So I'll say run a for loop from the last index till you have not reached the 0th index. Now here what you have to do is, as I told you, that in this question we will be using the concept of next greater element, wherein we use stack, right? So let's quickly declare a stack of integer type. So I'll say, I'll check. There would be a while loop, right? You'll understand why I'm doing all of it. Just be with me. That if the stack is not empty, and if whatever is present on the top of the stack, as I'll be pushing the index, not the number, right? So I'll say if temperature s dot top is less than equal to temperature I, then just pop out whatever is present on the top. Why am I running this while loop is, for example, you have come across a temperature, that means your current temperature, when you were moving from right to left is greater, right? That means you have to check for all the elements that are already in the stack to get an element which is greater than where you are standing, right? So this while loop is catering to that. I'll say if S is not empty, right? That means this while loop will stop only when it has found one element in the stack which is greater than where you are standing currently, right? Wherever is the current temperature. So it will say that if the stack is not empty, in that case, answer I, that means on the ith index of the answer, put, you have to now subtract it, s dot top minus I, right? Because we are pushing the indexes, that is why I have directly done it. And each case you need to push the ith index that you have just worked upon, and then you can finally return the answer. I think we're good to go. Let's quickly run it and check once. Okay, so we are getting this runtime error. What we can do is we can initialize this answer vector, right? Let's have it here and let us initialize it with the size n only. And initially let us assume that all of the next number of that day where the temperature would be warmer is 0 only. Now let's quickly run it. I think it should work now. And it is working fine. Let's submit it. And yeah, it is working. Okay, now let's have a quick dry run for this code and then we'll discuss its time and space complexity. Okay, so this was the code that we have just written, right? Now let's take this vector that has been given to me in the input, which is 73, 74, 75, 71, 69, 72, 76, 73. Yes. So this is the input vector that I have. Let's have a quick dry run. Now, what is happening is, initially I have declared something, as I know that this n here will be 8, right? So I'll create this answer vector of 8 size, 0, 1, 2, 3, 4, 5, 6, and 7. We have the answer vector here, and initially it is having 0 at each index. Now I'll create a stack here, right? So basically what is happening is I'm standing on my I is n minus 1, as n was 8. 8 minus 1 makes it 7. So that means I'm standing on the 7th index. I come inside this for loop. I'll check is the stack empty. And as you can see, yes, the stack S is empty. So we will not go inside this while loop. I'll check for this if condition. This is also not being satisfied. So I'll just simply push the index, and right now my index was 7. So I'll push it into my stack. After that, my I gets decremented. Now I am on 6, right? Now I'll check in the while loop that is my stack empty. It will say no. So that means this is giving me a true condition now. Now I'll check if temperature s dot top, that means temperature 7, that means temperature on the 7th day, is it less than equal to temperature on the ith day, and I is 6 right now, so 6. So I'll say that temperature on 7th day was 73 and temperature on 6th day was 76. So yes, it is true. See, if it is true, that means the previous temperature was lesser. So you do not have to keep it, right? So you can simply pop out. So I'll pop out 7. And as now my stack will be empty, so I'll come out of this while loop, right? I'll check, is my stack empty? Yes, it is. So I'll not work with this if condition. Then I will push my current index, that is 6, in the stack. Okay. So now my I gets decremented, right? And now my I is on 5th index. So I'm standing here. Now it will check, is the stack empty? It will say no. So now we'll say temperature s dot top. On the top of stack we have 6. We have to check that if the temperature on the 6th day was less than equal to the temperature on the 5th day. So on the 6th day we had temperature 76 and on the 5th day we have the temperature as 72. So this condition is not satisfied. We will not pop out the 6th index. We'll check now that is the stack empty. It will say no. So answer I being 5, I'll update this value. I'll say s dot top, that is 6, 6 minus I, that I was 5, 6 minus 5 makes it 1. So that means if I'm standing on the 5th index, for me to get the next closest temperature, which is greater than the current temperature, I just need to wait for 1 day. Okay. Now, this will be added into my stack. So 5 gets added into my stack. My I gets decremented. So now I'm standing on the 4th index. When I'm standing on the 4th index, I come to the while loop. As the stack is not empty, I'll check for this condition. I'll say temperature s dot top, that is 5. Is this less than equal to the current temperature I'm standing on, which is for the 4th index. So temperature at the 5th index was 72 and at the 4th index was 69. So it is not less than 69, right? So you will not pop out anything. And now as you are standing on the 4th index, you come and check the condition. As the stack is not empty, you will say answer 4. That means on the 4th index, whatever is on the top of the stack, that is 5. You subtract it from the current index, that is 1. That means if I'm standing on the 4th day where I have a temperature 69, I just need to wait for 1 day, because on the 5th day my temperature will be higher than the current temperature I am on, right? So it is 1. After this, I'll push my ith into the stack S. So 4 gets pushed into the stack. Now I'm standing on the 3rd day as my I has decremented, right? So now I'll check for the while condition. I'll see that if temp of 3 is, if temp of 4 is less than equal to temp of 3. Why? Because if temp s dot top, on the top of the stack I had a 4, is it less than the temperature on the 3rd day? On the 4th day I had 69 and on the 3rd day I had 71. So it is satisfying that yes, the current temperature I'm standing on is greater and the next day's temperature is lesser. So you need to pop this out. So this gets popped out from the stack, right? Now, this is the while loop, right? So it will again check. Now on the top, you have temperature at 5th index. You have to check, is it less than equal to temperature on the 3rd index? As you can see on the 5th index, the temperature is 72. On the 3rd index, the temperature is 71. So in this case, you will see that this condition is not being satisfied. Hence, nothing will be popped out as the stack is not empty on answer I, as I was currently 3. So on 3, I will have s dot top, that is 5 now. 5 minus I was 3. So it makes it 2. Okay. After that, I'll push my I into the stack. So now 3 is also added and my pointer is pointing to 3. After that, my I will become 2. That means I'm standing on the 2nd day. As my stack is not empty, I'll check if temperature s dot top. On the top of the stack, what do I have? I have a 3. So on the third day, is the temperature less than equal to what is the temperature today? That is the second day. So you'll say on the third day, we have temperature 71 and today we have a temperature 75. So yes, that is true. 71 is less than 75. You'll pop this out. Then you will check. I'll quickly clear some space here, right? Okay. So now, as you popped out 3, your pointer is again pointing to 5. That means on in the stack, the topmost element is 5. So you will check that is the temperature on the 5th day less than equal to the temperature on the 2nd day. So on the 5th day, temperature was 72, and now on 2nd day, you can see that the temperature is 75. So yes, even this is satisfied. So you will delete this also from your stack, right? Once you have deleted this, now your pointer is pointing towards the 6th day. So now you will check, is the temperature of the 6th day less than equal to the temperature of the 2nd day? On the 6th day, the temperature was 76. Today we have the temperature 75. So this is not satisfied. This is not popped out from the stack. And we come to this if condition. And on the second index, as the stack is not empty, on the top of the stack we have 6 and the current I is 2. So 6 minus 2 makes it 4. And 2 gets added onto the stack. Now my pointer is pointing towards 2. And my I has become 1. So that means I'm standing on the first index, right? So basically, I'll see that is my stack empty. I'll say no. Then I will have this check condition, right? Here now I'll say whatever is present on the top of the stack. And in this case, it is true. Is this less than equal to temperature of the first day? Because I was 1 now, right? We are here. So basically, as I am on the first day, I am checking is the temperature of my second day less than it. So temperature of my second day is 75 and the temperature of my first day is 74. So no, that is not true. You will not pop out anything. And now as the stack is not empty and I is 1, so you will say S dot top. You have 2, 2 minus I, that makes it 1 because I was 1, right? Now you are standing on the, and then you will push I onto the stack. So now I'm redrawing it here. My stack has something like 6, 2 and 1. Okay. Now what happens is my I gets decremented. It has become 0. Now when it is 0, I'll see as my stack is not empty, right? I'll check that is temperature of 1 less than equal to the temperature of the 0th day. So the temperature of the first day was 74 and temperature of the 0th day was 73. So that's not true. You will not pop out anything. In the answer vector, you will update S dot top was 1, current index was 0. So that means if you are standing on the 0th day, you have to wait for just 1 day to get a warmer day than the current day, right? And then you can push 0 here. And finally, as you have completed this for loop, you will get the required answer. I hope this was clear. Now let's talk about the time and space complexity. I think it is very clear from the code that we've written that the time complexity is O of n, right? And the space complexity is also O of n because we are using stack as an extra space, right? If you have any doubts, please feel free to reach out. Thank you. Please like, share, and subscribe.